All right, we're going to do some more best fit lines. This problem says an archaeologist wanted to find a regression line for human humerus and the femur bones. She took a random sample of university students and measured 7 people. Graph the scatter plot. So here's a scatter plot. We're going to graph femur on the x and humerus on the y. That's supposed to be an M. Now, the femur, that's our x-coordinate, goes from about 40 to about 60. So we could go up, maybe start at 35 and go up by 5s. Make sure these are evenly spread apart, and we should be pretty good. Now my y-axis starts at about 40 and goes to about 70. Yeah, we could probably start at 40 and go up by 5s also. 40. So you just want to pick some scale that will be able to display the data on your graph. And we don't have to use 0 in here. So this really isn't the x-axis or the y-axis where it will meet at 0, 0 here. But we can use this to graph our data. Now we have the point 38 for the femur, which is about here, 41 for the humerus. So we put that point on, 56, 63. Put that point on, 59, 70. 64, 72. 74. Oh, I didn't see these. 74. So 70, 74, or 75. So 74 is right in front of that, and that goes up to 84. Ooh, maybe I did this too. 74, 84, somewhere up there. 50, 58, and 62, 68. Somewhere in there. Now if I draw a best fit line, that's looking pretty good. You got about as many below as above. It seems like a pretty good regression line. Maybe something more like that. All right, so for a good regression line like this, we graph the information, and it said find the linear regression equation. So I'm just going to pick 2 points on my line from 40 and 45, and now I'm going to look at those values and head straight to the left and see what these would be. So this one is 45, should we say 51? That seems pretty reasonable. And this one is 40, say 45. All right, so if I take those 2 points, 40, 45, 45, 51, and I want to find the regression equation between those 2 points, first I need to find the slope, 51 minus 45 over 45 minus 40. So that's going to be 6 over 5. That's our slope. So this could probably be written as 1.2. If we wanted to write this in point slope form, we could say y minus 45 is equal to 1.2 x minus 40. Because this doesn't necessarily say what type of equation it needs it in. So that would fit for this. Or if we wanted to turn this into slope-intercept form, because it says down here we'll need the y-intercept, so we could do that. we could multiply this over the parentheses and have y minus 45 is equal to 1.2x. And now 1.2 times 40 is 48. Now I'll add 45 to both sides. So y is equal to 1.2x minus 3. So I would accept either of these regression equations for this first part. The slope, that's 1.2 in both of them. And to interpret that, we have to look at this. You go 1.2 in the y, so the humerus goes up 1.2 for every 1, the femur goes up. So say you could say for an increase in 1 unit of the femur, the humerus goes up 1.2 units. And I think in this, these should be centimeters, but it would work for any units. Now, the y-intercept, that's minus 3. So if the femur is 0 centimeters, the humerus is negative 3 centimeters, which doesn't make any sense in this context. So we would never draw this graph all the way down to 0 because it's only good, the data is good only in that range. Interpret the x-intercept. So to find the x-intercept, we put y equals 0 and solve it. Add 3 to both sides. Now I divide by 1.2. 3 divided by 1.2, oh, calculator says 2.5. So the x-intercept is 2.5, and that's saying when the y value, so when the humerus is 0, the femur length is 2.5 centimeters. And again, why would someone's humerus be 0 centimeters long? That doesn't make sense. All right, now predict the length of a humerus if the femur is 50 centimeters long. So I'll have to write this equation. Y is equal to 1.2x minus 3. And if the humerus, or if the femur is 50 centimeters long, we just put that in for x. So 1.2 times 50 is 60. 60 minus 3 is 57. Now predict the femur length if the humerus is 50. So if the humerus is 50, the humerus is the y. Now we'll add 3 to both sides. So that's 53 equals 1.2x. So now 53 divided by 1.2 is x equals 44.16. And that 6 just keeps on repeating. So that would be the length of the femur. Now predict the length of the humerus if the femur is 10 centimeters long. So forget the equation for a second. 1.2x minus 3. So the femur is 10. So 1.2 times 10 minus 3, that's 12 minus 3, or 9 centimeters. Predict the length of a humerus if the femur is 100 centimeters long. So 1.2 times 100 minus 3, that's going to be 120 minus 3, or 119 centimeters. Now, are the last two predictions reliable based on the data? No, we really don't know. This is what we call extrapolation. Because 110 are off the charts on the left side and the right side. So we would say, no, that's not predictable. Uh, because we don't know how the data behaves outside of our range. We don't know data that is outside of this range. All right. Now, hopefully you're ready to do the homework.